Hello, good evening, everyone. I am Sohani Baderia, Chairperson of IEEE Women in Engineering Student Branch Affinity Group here at UPES Dehradun. I am very glad to welcome you all to the inaugural event of IEEE Week 2025. To begin, let's take a moment to acknowledge the foundation that brings us all together, IEEE, the Institute of Electrical and Electronics Engineers. IEEE is the world's largest technical professional organization working to advance technology for the benefit of humanity. It brings together professionals from all around the world to collaborate, innovate, and contribute to solve real world challenges through technology. Within IEEE, we have a vibrant network called IEEE Women in Engineering or WIE. It is one of the largest global community focused on promoting women engineers and scientists and encouraging women to explore career in STEM. IEEE WIE was established in 1994 with the goal of supporting women in technical field, offering mentorship, increasing representation in engineering from classrooms to industries. We are excited to share that IEEE WIE Student Branch Affinity Group at UPES was officially formed this April. It stands as a step towards building a more inclusive and encouraging space for everyone interested in science and technology. Through this group, we aim to create opportunities for learning, leadership, and growth. And what better time to begin this journey than during IEEE Week, celebrated globally from June 23rd to June 29th. This week is all about recognizing the contribution of women in STEM and encouraging thoughtful conversation around diversity, innovation, and collaboration. Throughout the week, we have a series of virtual event plan, technical talks, hands-on workshop, discussion, and more.
Thank you, Suhani. Now let's move to our first event under IEEE WIE Technical Lecture Series, Talk O1, titled From Curiosity to Code, A Journey into Research and AI. We are honored to welcome our guest speaker, Ms. Manvi Jha, a PhD researcher in electrical and computer engineering at the University of Illinois, USA. She holds a BTech in electronics and communication from NIT Patna, and her research lies in the intersection of artificial intelligence, formal verification, and hardware design. Her recent work focuses on how large language models can assist with automatic code generation and correctness verification, an important step towards building safe, reliable digital systems. One of our major projects, Preface, explores how AI models can detect and fix their own errors in formally verified languages like Daphne, opening new possibilities in areas like chip design and AI safety. Apart from her research, Ms. Manvi is also a strong advocate for interdisciplinary learning and mentoring young minds. We're truly grateful to have her with us today. With that, now I invite Ms. Manvi to please take over.
Hi, thank you, Shelley, for the very nice introduction. Hello, everyone. I hope you're doing well. And it is such an amazing opportunity to witness IEEE WIE chapter starting and to see all the young women joining this and aspiring, you know, in progress in technology. So, with this, I would like to start sharing my screen and we can start with the presentation. Is that okay?
Yes, ma'am.
Okay. Okay, please let me know if my screen is visible.
Yes, ma'am, it is visible.
Thank you so much. Okay, so my talk is titled From Curiosity to Career, a Roadmap for Research Journey. I do not want to bore you guys. I know it's late in the evening. It's supposed to be a relaxation time. So it isn't going to be a very long talk and it isn't going to be very technical. We're just going to have a brief discussion of what's going on and how to move forward for any and everyone interested in research. Because, as said by Zora, I don't know if you guys know her, she's a very nice anthropologist and has written very nice books. And in her words, research is just formalized curiosity. So today, we're just a bunch of curious people discussing how to shape our curiosity into something that could benefit everyone. moving forward. So let's start knowing a little bit about me. I belong to Patna, Bihar. My education, I have done BTech in Electronics and Communication Engineering from NIT Patna. I'm currently doing PhD at the University of Illinois Urbana-Champaign. Uh, my focus for my PhD is to develop efficient large language models, something that we are using every day, but yet something that is not perfect for everyday use yet. My BTech research advisor was Dr. Ashish Kumar Bhandari, and he is my definition for research, the one who introduced me to this arena and to whom I owe basically my entire career. My vision is to build the next generation of intelligent systems because that is where we are heading. And I hope to have a world wherein we can automate stuffs from the smallest to the largest, yet not replace human work, something that has been troubling people recently. My areas of interest include computer vision, large language model, hardware co-design, and formal verification. I kind of merge all of them to create a fully automated system. You can find out more about me on my website and feel free to reach out to me on my email. Uh, I would like to start the talk with a brief discussion on what I have been doing recently. As told beautifully in a brief intro, my recent work is called Preface. In fact, I'm at a conference pitching it right now, so this is very recent. What this work does is basically it is a reinforcement learning guided framework that helps large language models to correct themselves when they are generating code. Now, code generation is something that as engineers, all of us have done sometime or the other with the use of ChatGPT. It is good with Python. I really applaud it for that. But if you ever switch languages, you would see it's not that great. One of that switches leads me to Daphne language, which is a formal verification engine. With formal verification, you can verify codes mathematically, so you do not need to provide them test cases. That is a more, I would say, robust way of checking how good a certain algorithm is, because then you know that all the edge test cases would pass. So when it comes to writing code in such languages which needs to be formally verified, I would say large language models are pretty pathetic. But the good thing is that to help them improve, what you can do is you can teach them. There are many ways of teaching large language models, uh, but there are also issues with that. So let's go to why this project is important. First, as I discussed, of course, formal verification is strict and ChatGPT isn't good with it. Generally, what people do to improve large language model is that they fine tune it. They take a big data set, they tell the large language model, oh, hey, you see, this is something that is specialized in the field that I want you to work on. And just go ahead and learn this data and then just produce the results that I want. But then we do not have such big data sets for formal verification languages. Additionally, fine-tuning such big language models, we're talking language models of size like billion parameters, or 170 billion, that's the recent size of a llama model. So it's like a big model that we're talking about. Fine-tuning that would take thousands of GPU hours and months of your time. So it's also not a very computationally efficient way. So then I come up with this idea. How about we do not fine tune it? We teach it the way we teach students, the way we tell them step by step, or here is what you have to do. Because it knows what it's doing, it just doesn't know how to do it correctly. So we switch from fine tuning, which is the conventional way, to prompt engineering, but not by humans, because that is maybe subject to still a lot of human errors. So here is how we proceed. We use a reinforcement learning agent, and this agent is supposed to improve the prompts every time it passes it to a large language model. No fine tuning is required. LLM just gets smarter itself. To be more detailed, if you can, let me get a pointer actually. To be more detailed, we have a problem description in natural language, the way you and I talk daily. And we just pass it to a smaller language model, which is much easier to train, much faster to deal with, and much smaller in size, but yet efficient. It is not as efficient to generate codes and to do logic here, but it is efficient to understand the task. It is efficient to draw out, say, maybe a few steps or maybe a few instructions. So what we do is we make this our reinforcement learning agent. And through the entire loop, we train the small language model to generate prompts which have exact instructions what would help the larger language model, which is basically frozen. We do not alter it. We train the smaller language model to understand the behavior of the larger model and generate exact instructions. So it's kind of tailored to the larger language model. Every time this larger language model generates some code, we pass it through an integrated verifier. This integrated verifier is the key part of the reinforcement learning model because here we see whether it passes generate errors or whether it's trying to do reward hacking. If it's just generating an empty file, that would pass every time, right? So here we generate the rewards, pass it back to the small language model and be like, so this was your performance. Could you please improve it? And that's how the cycle goes unless we get a verified code. And that is how we train the smaller language model to generate prompts good enough to instruct the larger language model to perform well. Now, this sounds like a huge flow, right? But interestingly, it's also a very efficient one. So we can see the results. We tested it on a test bench of 100 samples. And here is what the results look like. So let me just focus on one of the graphs first. So if we go with, say, a situation wherein we have the trained SLM with feedback, which means the entire cycle, we use a small language model which is not trained, and then we do not use a small language model. There's no instructor. We just leave the large language model on its own to decide what to write. And we can see the change in performance that we have. For instance, for my language model like Quen, the performance went all the way from 21 to 31. For Quen's smaller model, like just 7 billion parameters, it went to 11 all the way from 7. For Gemini, it went to a sharp 55. And for our favorite ChatGPT models, it went from 36 to 50. That means that 50 cases were possible to pass amongst the 100 that we were testing. And similarly for ChatGPT o1, it went from 35 to 52. So it was a successful study. And this clearly showed that with just prompt altering, we can improve the performance of language models a lot. Now, what do we do after we have this formally verified code? Interestingly, for Daphne, we can compile it into a bunch of other languages. We can compile it to Python, we can compile it to C, we can compile it to Java, we can compile it to whatever we want. And from there, we have a code which we know has been previously verified is 100% correct, passes all the checks that you want, and is in your language that you want. So that's a bit about the work that I have been doing. I've been super excited to share that, and I wanted to share it with you and to give you a picture of what research here looks like. But then something that might be popping up in your mind when I am like telling you all about research and all about my work and this entire week of women in engineering, and we start with a career in research. So like, why research? There's a lot of job opportunities out here and there's a lot of things people can do. So to convince someone to be into a particular field, you need to give them a proper why. So for me, the why was I always wanted to be a scientist and I just didn't think after that. But then there needs to be proper more reasons. Research is basically curiosity. You start with just some curiosity that you have, you go to an innovation, and then that creates an impact. The impact is big enough for the world to know what you've created, for the world to start using your work. When you see a bunch of people out there citing your work, looking at what you've done and coming up to you saying, hey, I saw your work and I've been using it, it's interesting. That is a different level of feeling. So I would say impact is my favorite part of it. So every research starts with a question. Why does a particular thing fail and can I make it better? For instance, in the slides that I just shared, we started with a question. Why are large language models not good with formal verification codes? And why is it so difficult that we just have to do fine tuning? Why can we not reduce the time? Why can we not reduce the computation power needed? So why are these bottlenecks existent? And how can we change that? Because unless you question the change, you're just going to be stuck at a point which is not very comfortable. So progress starts with failing, and progress starts with thinking on how to change the fail. So then research gives you an opportunity to fail as much as you want, change it, make it into something better, and create a larger impact. It turns your ideas into reality. It turns all those wild thoughts that you've been having about an AI doing your cooking to actual reality. You can actually do that. So, everything that you've thought, everything that you can imagine, you can actually be the one to transform it. So it turns your ideas. And even undergrads, they are contributing to major breakthroughs. Some of the best papers that I've read so far have been contributed majorly by undergrads. And it is interesting to see how much impact can be created by such young minds. It is rather weird to think that undergrads would have less impact. It's not. If you as undergrad think that, oh, research is something like really big, because I had that thought. It's not really that. You just have to get in, put in your potential and work, and you can make really big differences. So why not start just now? Additionally, research gives you a very competitive edge. So if you have research experience, your CV instantly stands out. Now, that standing out CV can be used for further education if you're interested. It can be used for your internships and jobs. Companies favor and select people with research experience with blind eyes because they want innovation. Everybody is moving towards something new and they want people who is at the frontier of it, who knows what's happening and who knows what's changing. So everybody is going to prefer someone with a research experience. So definitely that's a great add-on to your CV. And it can help you get into national fellowships. It can help you get into MyTax and that. And I'm telling you, MyTax is really interesting because that gives you a chance to go all the way to Canada for an entire summer. So, it opens your doors to nice experiences, to great CV, and definitely great career opportunities. So no matter where you're looking your career to be at, if you're looking at research or you're looking at industry, research definitely helps. But the question is, okay, it's interesting, but how do we start? So the start can be a bit overwhelming. I'm never going to lie, it was overwhelming for me. So the first thing to do is to explore and identify your interests. Think about what class made you go like, oh my God, let me look more into it. Or what particular, say, hackathon, or I don't know, some talk, or some professor's ideas, or some discussion, some blog that you read made you go like, this is something I can just never stop thinking about. And you should definitely never stop thinking about it. Just go deep into it, read about it. And the more you go into depth, the more you'll be like, wow, people are doing stuff that is really interesting. And if you really like the topic, you would never stop exploring. So the first thing to start about is, what do you think is cool? You should love the topic enough to not hate it when it fails, because once you start to research, it's going to be a path wherein you explore something which is very new. When you're exploring something new, it will have its own successes and its own failures. It will have its own ups and lows. I have seen people starting research, getting to a certain point, but the moment they face their first hurdle, the moment they feel that, oh, this is difficult to deal with, or this is not going the way I wanted, or, you just run a code and all you get is a black screen. You can face that, but you have to love the topic enough to not stop there, because I have seen students stop at that point, and that is not great. So you need to choose a topic that you can love at its worst. You need to follow your interest. You need to read blog posts, watch tutorials, and read papers. Now that's in bold. So when I started my research, my undergrad advisor, every time I used to go to him with some kind of problem, he used to be like, Manvi, you should read more papers. And at that time, I used to be like, well, that's a lot of work, just reading papers. I am never going to say that to anyone. But then when I started into research, when I got in depth into it, I'm like, that's the actual only solution. The more papers you read, the more you know, the more you understand the topic, the more ideas you get. It's crazy how much ideas you can get by reading papers. And at the first look, papers can be overwhelming. I would say just start by abstract. But once you get a hang of it, it's interesting to read. And it's definitely the solution to everything. So, yet after this talk, you're going to open a paper and be like, that's a weird suggestion. And if I go and tell someone to do research, I won't say that. But say, like a few months down the lane, if you're still into research, that's the first suggestion you're going to give to anyone because that's how useful the suggestion is. Reading paper, it changes everything. So, how do you start from where you are? Explore your department's research. Go to different labs, go to professors, see what they're doing, read their papers online, talk out to PhD students. What is it that they're doing? What is it that interests you? Read about their research, talk about their research, and interact with them and reach out to them. Reach out to the professors, say that, oh, I read such and such book of yours and I am interested in knowing more. Can we maybe have a meeting or can I maybe have the opportunity to work with you? Be very respectful, but do not always expect a reply. Professors are really busy and they do not always reply. This is something my senior told me. This is something I faced. And this is something I tell everyone who ever reaches out to me for further studies advice or for reaching out to professors. They read your email. They will definitely reach out or reply when they feel that they have the opportunity that you're looking forward to. But do not expect to reply the moment you send an email. That's not possible. But do not be disheartened by it. Keep trying, keep pushing, read more papers, reach out to more professors, and just don't give up. It's a very relentless field. The question is, what is a good paper? I keep repeating, read papers, but like, what is it that you should read? So, first thing, why reading papers matters. As I said, you would get to know what is exactly going on in the world, what is exactly going on in the field. Because many a times we feel that we know what the recent advancement is, but until we are reading the papers, we just know what the recent production is. We know the products that have been put out by the businessmen, by the industry for public use. We know that because that is something we use, we see. But we do not know what the next best thing in research going on is, or what is the frontier that people are actually sitting at. What is it that everybody is working on right now, given this moment? So, understanding the frontier is important because if you don't, you work on something that's probably outdated, it is not going to receive as much of a notice as something or as much as of attention as you would expect it to. So, understanding the frontier, and the only way to do that is read papers. Build up a technical depth. You'd know about techniques, data sets, and tools that you probably might have not heard about. Honestly, the only place I got to know about data sets was research papers. So you would learn a lot about technical details, much, much wider than just the textbooks. Now, the textbooks are very important to build your basics, but when you're standing in the front of it and when you're wanting to make a change, you need to know the first thing in technology before it comes out in books. So that's where you build your technical depth. It can improve your writing and structuring. It's interesting how much of an improvement reading research papers can bring to your life and in general to the way you write and talk. It can inspire new ideas. You would have a lot of new things to think about because when you read someone's work, say I presented my work today, a lot of you might be having a bunch of questions that, oh, why didn't you look at it from this perspective? Or why didn't you think of it from a certain angle? Why didn't you use the other approach? And there can be a lot of questions. And I'm telling you, a lot of them would be something I never thought about. And maybe talking with you or talking with someone in general would be like, oh, yeah, I could have done that. So when you read papers, or when you hear talks, or when you see people's work, there are a lot of questions that are going to come to your mind. And remember, when I said research is about thinking, what can fail and how can I change it? So the only way to understand what is failing is to see what is happening. So just read papers and spark new ideas. And then you will be able to definitely target the right ideas and the right problems. But what makes a research paper worth reading? What paper would it be that you'd pick up and you'd be like, okay, I'm going to read it? Or what is it going to be that's going to be just like lying in your drawer forever and ever? That I don't know why I printed it kind of paper. So, what makes a paper worth reading? It should have a very, very, very clear problem and motivation. Why is this topic important? what is the issue that's going on, and why should I be interested in this? So a paper which has a very clear motivation, or a motivation that sounds clear to you, is the one that you should be reading. It should have strong citations and be accepted at a good place. Now, citations which are, say, from 5 years ago aren't as good because then you're not at the front of the research. Strong citations means that the paper, citations usually refer to, related works, the works that are kind of related to the topic that you're dealing with or the approach that you're dealing with. So if you have citations which are very recent, which are very strong from like big journals and conferences, you're probably reading a paper which is dealing with something very, very, very front of the research or very interesting or very impactful. So that is definitely something you do not want to put down. If it is accepted at the top venue, it definitely went through rounds of review and it is a very good read. If it has an open source code and is reproducible. Now, let's not lie, a lot of research papers out there which are published in not such good journals or not such good venues or which are basically just for the sake of existing, some of them aren't very good and you probably do not want to waste your time on that. So if a paper does not have an open source code or does not clearly mention how to reproduce their methods to get the exact results back, is probably something you would want to avoid because that's a bit of a question mark as to why aren't you being open. The research community is all about helping others grow, publishing your work, making an impact, making your work useful for everyone. So if a person or if a certain research is not reproducible, it's not pretty much acceptable. You should have a very reproducible work. Now, this is something which is very centric to the areas that I have read or dealt with. It is very much possible there can be research areas out there which do not support reproducibility as such. But being in the field of engineering, as all of us are, I would doubt there are any such fields in engineering as such. So we can just go by this. It should have good figures, diagrams, and logical flow. That shows the clarity of the paper, how well it was designed and defined, and how much the author put a thought in it, how much of a clarity the author had about, or how much of a grasp the author had about the topic. So good figures and diagrams and logic flows are always a plus. And if you want to start, just read the abstract, read the introduction, read the conclusion. If you feel that this is something that is really interesting, it's interesting, you would want to see how the author got the results they're sharing, then go ahead and read the methodology. That's how you find a research paper that fits to your needs. Where to look? Where do you find these papers? Google Scholar. I always go for Google Scholar. Search it. The first thing it might be something that's interesting. Do not hesitate to look for archive preprints. I know a lot of people have reservations about it, but honestly, I feel a lot of good works are shared on archive first before they're published at top conferences or journals or venues. So if you know how to differentiate a good paper based on some of the pointers that I shared in the previous slides, you can probably find some of the best works on archive. There have been instances where you can literally see a work that comes out, gets really famous, gets a lot of citations, and 4 months down the lane, it's been presented in a conference. So you already had a preprint of it, the paper already gained fame, it's just formally being presented somewhere. So it's interesting how great works you can find at archive. So always a great place to look at. You should go for top conferences. Some of the areas that I've listed are the ones that I have experience with. You can definitely explore the ones that you're dealing with. Just Google the top conferences in your area. So, for if you're interested in MLAI, I would probably suggest NeurIPS or ICLR or CVPR or something like that. They have really good papers. I should have also mentioned ICML. That's also good. If you're into systems or EDA, you should go for DAC, FCCM, or ICSA. DAC is the conference happening right now. I'm at San Francisco attending it. It's a really nice conference. And if you're into computer vision or language models or something, you can try ICCV, ACCL, AAAI, something like that. You can always go to university lab pages, the labs that you're interested in. They always share their recent works and papers on their web pages. So do not hesitate to look out there. And if you want to go, just ask your seniors and your advisors. They have the best papers in stock. So ask them for research papers. Start reading. The more you read, the more you understand, the more you explore. Once you've read and you are into research, how to write a good paper. Now, this is not just for papers, this is for any kind of technical writing that you do. Writing is a very important aspect. It's more about how you sell your work than how you do your work. So, a good paper is something that is going to get a lot of impact from everywhere. So, your paper should, as I mentioned, have a very clear problem statement. Why and why does this problem matter? And what is the challenge that you're trying to solve? It's the most important question to answer. It should have a well-defined motivation, which should clearly state that your problem statement has not been addressed yet. That is an academic gap, and you would like to be a part of the group trying to address the gap. Remember, you're not going to be the only one solving the problem, so there are going to be a bunch of people solving it, but you should have some methodology that you feel should really stand out from everyone else, because novelty, you can see a marked novelty in red. There's a clear difference between a research work and an engineering work. An engineering work is just a pipeline. It can have a bunch of existing things stacked together, just working. That's engineering pipeline. It does not need to have a novelty. It's just engineering work. It's something that is making a particular or meeting a particular task, making particular tools work. That's engineering. But when you're into research, the most important thing to have in your work is novelty. The work that you're presenting, the idea that you're showing, should not have already happened. It should be new. It should be improved. It should be something that is, it's like you gave birth to the work. So novelty is the most important thing when you're like proposing a research paper. If it's just a technical paper or an engineering paper, it can always have less novelty. I would say you should always have novelty in your work to make it stand out, but it can still be less for engineering works. But if it's a research paper, it's it's supposed to have a big amount of novelty in it. It should have experiments and results. Just proposing an idea isn't really enough unless you can actually show how good this work is, or does it really work in real life with real time data or real time objects. And the writing structure should be clean, logical. It should be able to tell the story clearly. To someone reading it for the first time and to someone who is an expert in the area, it should be able to display the message to everyone. So a good paper teaches something new, answers why, and clearly shows how, like very clearly. You can also see this image. I found this on Google and it's really interesting how well it outlines all the sections. So there's like supposed to be an abstract and keywords, which should be a descriptive information and lets the reader know what the article is about. There should be an introduction, which should tell the context of the project and give the problem statement. There should be methods, which should say how the authors solved the problem statement. There should be results, very important. And then there should be a discussion on how good, bad, significant, important the results are. And then definitely there should be references. Obviously, any work does not start on its own, it is originated from somewhere. So have references of where you started it from. Since we are on the topic of writing, let's deal with what good sections look like. So the abstract should start with stating a purpose, like, oh, this paper tries to investigate something like this. It should be summarizing what was done. How did you go about doing it? How was the data collected? How was the pipeline implemented? And it should highlight the achievements. Oh, we achieved 21% of gain. We achieved, say, 5% less time. We achieved the complexity of O1 or something like that. The introduction should establish facts. What has already been done? How has it been done? And it should then describe what you are doing. Now, when I say introduction, I'm kind of trying to merge introduction and proposed results because some papers have separate sections for it. Some people have like same section for it. So you should have like a part that says what you did for your contribution, and that should be an active voice because that's something that's going on, and what has already been done is past. There should be a methodology section which says what was done in the paper. It should be in present passive because it's present, it's going on, but it's kind of just what you did after before writing this paper, right? So it's present passive. And then how you collected the data and everything. So it should have all the information about how the method was implemented. There should be a results and discussion section, which should show the figures, the tables. Try to have tables every time. And it should have a status on how improved the work is from the past work. Say like, oh, the method was improved by 12%. Now that's good because 12% improvement is a huge improvement. So it should have like, oh, this is what we achieved and this is how much better we are from what is existing. And it should suggest what should be done next. So how do we proceed further? If somebody is reading your paper and is really interested in the field, what should they expect next from you, or how should they reach out to you to collaborate on next steps? What should the next step for this work be like? So there is no topic that would end at what point you're doing it. If you've improved it to some extent, there's always some scope of improvement left. If the improvement is done, there's always some kind of application left. There's always some extension of it left. So there is always a future work, and that is where people reach out to you. That is where you move forward, or that is where somebody interested in that area would read your paper and be like, okay, here is how I want the world to move forward. And then definitely it should have a conclusion as to what was done and what is expected. So that was a lot about what research looks like, what to read, what to do. Now let's get to the big question that I get asked almost every time. I know I'm covering a bunch of topics here, but I wanted to give a big picture on everything that I would expect in my BTech to know when I wanted to start research. So say you've started research, you've read a lot of papers, you wrote a good paper. What now? Like, great, it was a great research journey, you loved it. What after BTech? So after BTech, you have two tracks. You can, if you want to go to further studies, if you want to get a job, of course, you have a great CV. Just go ahead, apply to industries, and they would be more than happy to take you. But if you want to go for further studies, there are two tracks that's possible. You can do a master's or you can do a PhD. A master's is a 1 to 2 year program. A PhD is a 4 to 6 year program. A master's would help you develop your skills more in an application-oriented way and would prepare you for an industry job, which you would probably take after master's. A PhD would help you get into deep research, get to know your topic the best way you can. Funding opportunities, another big question that is literally filled up on my LinkedIn even right now. So it's like MS is usually partially funded. With that, I mean, if you get into a program where you're accepted for MS with thesis, or if you are in a lab which has good funding, or in a university which supports funding for MS, you can definitely get funding for MS. If you are in a university that does not support it, you can apply for partial funding through TA-ships or RA-ships or something like that. So to get into more detail, when and if you have funding, the things that it covers is that you wouldn't have to worry about your fees. You wouldn't have to worry about your education. It covers all of that. And then it gives you a certain amount of income, monthly stipend, to continue your work, to continue your research. Now, just to make clear, I should have mentioned that already. This is something that I'm talking in context to study in abroad. I'm not trying to like force anyone to come abroad. It's definitely a choice, but this is some kind of question that I get asked every time, and I wanted to bring it out to everyone because I think it's an important information that everybody should have. I'm pretty sure the programs, the master's and PhD programs in India have a pretty similar trajectory. But the exact information that I'm sharing is very much oriented to my application process and the education system that I'm seeing here in the United States of America. Um, with a PhD, you almost always get full funding, which means you do not have to worry about your fee structure or your courses or your in general academic fee or any kind of fee, you get a monthly stipend to carry out your research. You have to focus on your research and on teaching classes, whatever it is that your university wants you to do. MS is great for upskilling and entering into research heavy jobs if you want to stick to research, but not so much that you get to a 6-year commitment. You probably want to go for an MS. PhD is for those who are passionate about the area that they're working on. If you just cannot get enough of the field, you enter into a PhD. Now, what does an application, if you want to get into further studies, if you want to apply abroad, if you want to get into one of the universities in the United States, how does an application look like? What are the stuff that you need to prepare for starting now, today, right now? The key requirements for an application would include a statement of purpose, which highlights your journey, your interests and goals, and what you've been doing, a detail of why your profile or why your application is really outstanding. Letter of recommendations. Now, this is why you should start working in labs right now, because then you'll have people who can recommend you. I always suggest having letter of recommendations from professors or, I don't know, lab advisors or somebody who you have very closely and academically worked with, and your CV. It should highlight your skills, your projects, your internships. It's always good to have as much projects as you can in your CV, because that shows how much hands-on experience or how much real in-depth understanding you have about certain fields. You would need your transcripts, that's your results for each semesters, and you'd need TOEFLs and sometimes GRE. The GRE requirement is quite shaky. Some universities have it, some don't. The bonus is always going to be your projects, your research papers, your hackathons. The more you're involved, the more you can show that you really are passionate about this field, the better your profile gets. And there's no particular exam that you have to qualify to get into the universities here. For instance, I know in India we have GATE, and that is the exam that you need to qualify to get into universities for your masters. Sometimes even for PhDs, they accept GATE scores. But mostly for PhDs, I would say even in India and in the United States and in Europe, and also for masters in these foreign countries, they depend on your profile and not so much on a particular given exam. So it is always suggested to build as good of a profile as you can. How to build a strong profile? You should have a good GPA. I have had a lot of people ask me if, oh, I have such and such GPA, is it good? Well, there is no good and bad. It's about how and why you have that CGPA. If you haven't had a lot of research projects, hackathons, or other projects that you were involved in, you were probably just studying all the time, then it is expected to have a high GPA. But if you have a lot of research papers, if you have a lot of open source projects, you can probably tune down that CGPA by a few points. And you would still be good because then you can always be like, okay, I was shaping myself in a different way. So there is no particular border that, oh, just have a CGPA above this, but try to have as good as possible or try to have as reasonable as possible. Research should be something that you can start as early as possible. There is no late or early in it. Just start whenever you feel that, this is the time I want to start. This is the time I'm interested in. Just start it. It's a long journey, so you're going to take time to get a hang of it. So start whenever you feel like, but I would always suggest early. Try online courses. They help a lot. Believe me, online courses help a lot. That's why I specifically mentioned a few here. And I always suggest having online courses. So that's a good thing. Have a network. Now, networking is very important. The more you reach out to people, the more you learn about their experiences, the more you know how and what they did, it gets better. Even if you're applying to universities and you probably want to know which university is offering, say, like good funding, which labs are open to accepting students, the only best way to know that is to know students from their labs or to know students from those universities. And to do that, you need to have a good, strong network. So you need to share your work to this network. You need to be connected to this network. You need to be on a network. And to do that is to always, attend workshops, join courses, go to student conferences, be as social networking in terms of academia as you can. The SOPs, as I already shared, it should have a clarity of what you did. It should mention projects and professors that you worked with. It should be something that the committee reviewing it would know, yes, you did it and you personally wrote it and it's not taken by some AI, or not just, you just didn't copy paste a template. It should be very personalized, like, oh, I did this project and these are the challenges I faced in it and this is how I overcome it. So it should be something that tells your story. You need to put your story out and then leave the rest to them to decide if they like your story good enough to have you in their university. The don'ts: do not copy templates. Believe me or not, they have seen all the templates that's available online, so you can never find something new. Do not be over flowery. Do not use a bunch of high level Shakespeare words. That's not going to change anything. Don't copy paste stuffs. Do not list your CV again. Do not go like, I have this CGPA, I did this education, I did these courses. That's already in your CV. That's not something they're interested in. They're interested in what's not there. So those are the do's and don'ts of the SOP. This is how you can write an impactful SOP. And finally, start small but stay curious. That's the suggestion that's the motto everybody should have. Do not fear rejection. That's research. You're gonna fail, you're gonna start again. I remember, as Einstein said, there was this one time when I'm wrong. When Edison's lab was all burned, his research paper was lying in ashes and his works were done with. And that's when he said that he's happy that he has the opportunity to start all over again without the mistakes that he did previously. So now he'll have a more clear trajectory of his research. That's how motivated you have to be when you're in research, because you are trying to find out something new. You're trying to create something that is not existent. That is not going to be easy. It's going to be difficult, but you have to be steady. You have to be regular with it. You have to write often. You have to code often. You have to read every day. And you need to find a very nice mentor. A nice mentor can change your life in ways you cannot imagine. So the best time to start was yesterday. The second best time is today. Start now, start small, and just get into this beautiful area if you're interested into it. That's pretty much all I wanted to share. It was a lot of information cluttered together, but I hope I was able to deliver a clear message. I am open to questions now if you guys have any.
Thank you for the insightful session, ma'am. Your talk truly gave us deeper understanding of how research and technology go hand in hand and how curiosity can lead to the real world impact. We're grateful for the time you spent with us today and for sharing the journey and knowledge so generously. It has definitely sparked new thoughts and inspiration among all of us. And I
Thank you.
think we do have some questions. Uh,
Sure. Let me just stop sharing and we can interact. Yeah.
okay. So I think we have the questions in chat.
Okay, yeah,
Yes,
sure.
we
I
do.
can I can refer to that. Okay, so the first question is, how can students improve their chances of getting full funding for PhD? Okay, so mostly for PhD, I would say unless you are getting into a university that is struggling with funds on its own, you are pretty much always guaranteed full funding. In general, to improve your chances of funding for any kind of course, master's or PhD, I would suggest to have as good of a profile as you can. The better profile you have, the more are the chances of getting accepted directly into a lab. And if you're accepted, say, under a professor or in a lab, that guarantees you funding from the lab. So the better your profile, the higher are your chances of funding. Um, the next question is, how important is formatting of research paper, and is there a way to get a standard format? And how much old can the references be? Okay, this is a very nice question. So formatting of research paper is very important. If you write a paper which is, say, out of format, which follows a structure of its own, it's going to be not as openly accepted because there is a standard that everything follows. There is a format that is being presented. That is how you, say, like present your work or write your work, which has been meticulously designed so that it can bring out your work in the perfect way. So yes, formatting is very, very, very important. And the way to get a standard format, it depends on what you're targeting. If you're targeting a conference or a journal or which, just go to their website, go to the place that they, have, or submit a paper or something. They'll have the format or the template present there. So they'll have it for Word and for LaTeX, whichever one you prefer. You can just download it from there. For references, again, what I'm saying is very much associated to AI field. So in AI, because it's a very fast moving field, I would say the references should not be older than 2 years. That's the oldest you can go. But if you are, in an area which is fairly steadily developing, uh, something like, I would say, antennas. It is a very good field, but it is also something that steadily develops. So over there, I think maybe you can have references a couple of years older too. But definitely do not go much more than 5. I think that should be a hard deadline for any field we're talking about. Um, is it better to gain work
Choosing on,
experience? Sorry?
I guess those who wants to inquire about something or has a query can like raise their hands and ask, open their mic and ask. Feel free to ask like
Yeah,
that.
yeah, sure. Yeah, that would be great too.
Okay. So I guess Angel has a question.
Yeah, I've also mentioned it in the chat box. So, is it better to gain work experience before applying for an MS or PhD?
It is definitely good to have work experience. I wouldn't say either of the thing is like a hard preference. Like, it's not that if you don't have a work experience, it's going to be bad, or don't have a research, it's going to be bad. It's just a thing that you prefer. If you want to have work experience before applying, that is definitely going to add to your profile, and it's definitely going to be good. The thing that it's going to restrict you to is that if you have work experience in a certain field, switching the fields from there would be a bit challenging because then everybody is going to be like, okay, you have experience over here, you should probably stick to it.
Also, I want to add on to that what challenges did you face while writing your first research paper?
Oh, a lot of them.
I'm just so
I
curious
remember.
to know.
Yeah, sure, yeah. So I wrote my first research paper. I think I was in my second year. I'm not sure. It was either second year or early third year. And it was a very, I would say, interesting journey. So I read like a lot of papers before that. I wanted to be, as good as possible. After I sent my first draft to my advisor, he was like, "Oh, good job because you did as an undergrad, but here are the comments." And that was a pretty big file. There were a lot of changes. There was a lot of places where so there are very intricate things that you want to keep in mind when writing research papers. For instance, you cannot have capitalization in between. You do not miss punctuations. You need to be very particular in how you're stating facts, and if you write something, it should have a proper citation. It should have a what and why along with it, like why you're stating it, how you're stating it. So yeah, it was, what I wrote was pretty generic, and then I got a big review file on how to improve it. So yes, so my first experience was, it was very challenging. It was filled with errors, and yeah, and I had to go through like 4 or 5 iterations to get a final draft, which my advisor was happy with. So it is challenging, but it's interesting. I would definitely say I love the journey.
Okay, thank you. That's all
Sure,
from
yeah.
my side. Anyway.
Good evening, ma'am.
Good evening.
Ma'am, I have a question that I started my research topics and I've started researching on certain topics and projects, but I am currently struggling in what tools I should use for documenting my research for the paper. Like any specific tools you are gonna suggest us?
Tools as in documenting what papers you have read and keeping a track of what's going on. Is that what you're asking?
No, for writing my own paper.
Oh, for writing your own paper. Okay, so I mean, I wrote my first paper on MS Word, but now that I have moved forward with like writing papers, I would definitely suggest LaTeX using Overleaf, because that helps with formatting a lot. It deals with a lot of formatting errors on its own, so that's easier to write on. So definitely go for Overleaf and keep a track of the papers that you've been reading. You probably want to like put a reference on all of that. You can also use open tools like Medley. I think that is helpful. I haven't used it, but I have had peers who've used it. So that helps you get citations and find related works easily.
Okay, thank you, ma'am. That was very
Sure.
helpful.
Sure, yeah.
Ma'am, I have a question. It's like, is it important to refer to journals, like alongside with conference papers?
Uh, so it's not necessary that every conference paper would have an associated journal. So alongside a conference paper is something that is not a necessity. But yes, journal papers are definitely way more detailed than conference papers. So based on my experience and my suggestion is that you should start with journal papers because they have more pages, they have the liberty to write longer papers, so they have more details. So it is better to start with journal papers to have like a more in-depth understanding of what's going on in the topic or in the project in general. And once you have a knack of how research paper flows and what they mean when they write a few sentences or when they write a certain structure, then you can maybe probably switch to conferences. So you should definitely start with journal and try to get journal papers from IEEE, ACM, and like the famous journals. I think ASME is something that's famous for mechanical. So yeah, try to get papers from there.
Okay, ma'am, thank you.
Sure.
So I guess nobody has any more questions left.
Sure.
Okay, so thank you once again, ma'am. And to all the participants, thank you for being such an attentive and enthusiastic audience. Your involvement made this inaugural event of WIE Week even more special. And a really heartfelt thank you to Mr. Rakesh Ranjan, Faculty Advisor of IEEE SPS, for his continued support and guidance throughout. This was just the beginning. Many more engaging sessions await you in the coming days. We hope to see you there. And thank you once again. We had a great evening.
Yeah, thank you so much for inviting me and having me over. And thank you, Professor, for extending the invite.
Thank you so much, ma'am.
Thank you.
Thank you, ma'am.